Hello, I'm Professor Ian Hunter and I run the bioinstrumentation lab here in mechanical engineering at MIT. And I'm joined by my colleague, Dr. Kathy Hogan.
Hi.
And together, including the help from a number of very, very talented students and postdocs and others in the lab, we've created a very interesting new technology for drug delivery.
What you're watching is a simulation of drug delivery into the skin, in this case of a particulate, but not using a needle. We're developing a system that eliminates the use of needles and instead delivers drugs into tissue using a high-pressure stream right into the skin. In our lab, we've developed a prototype of a device that uses a highly controllable jet injector and a computer interface that controls volume of drug delivered and the velocity at which it moves. It can both inject into and aspirate from tissue.
And we're able to fire the drug out at almost the speed of sound, if we need to. The speed of sound in air is about 340 meters per second. It's capable of pressurizing the drug up to as much as 100 megapascals. And we can do that in under a millisecond.
So here you can see the heart of the Lorentz force actuated, the heart of our actual technology.
There's a magnet in the center of the jet injector that's surrounded by a coil of wire. And when we apply a current to the coil, we create a Lorentz force that pushes this piston, which forces the drug out of the ampule. This gives us a tremendous amount of control depending on how much current we put in, so that, as you can see here, we can successfully deliver a wide variety of volumes of drug at a wide variety of velocities with a very low degree of error, something a needle can't do. We can also change the velocity over the course of a single injection, so it breaches the skin at one velocity and then disperses the drug at another. We accelerate the coil to the desired speed, hold it there for a defined time, and then decelerate to a lower velocity to disperse and absorb the drug into the tissue.
So the drug comes out at this fine jet, about the same diameter as a mosquito proboscis, and as many of you know, you don't feel when the mosquito inserts its proboscis into your skin because it's so very narrow. Our jet is of a similar diameter. We've also developed this device so it can be used for delivery of drugs right through the eye into the retina. We've succeeded in delivering drugs through the tympanic membrane in your ear so that we can deliver drugs to the middle and inner ear. And we've also done something that we think is pretty cool. We can take a drug in powdered form, put it in this device. The device, because of its very, very fast response, is able to vibrate that powder so it behaves like a liquid, and then we inject it into tissue as though it was a liquid, even though it's a powder.